We started out this course by learning how to transform data. Then we learned some things about how to study inequality. For instance, how we could think about disparities by race and disparities by class. Today we move on to the ultimate goal of the course, asking our own research questions. By the end of class, our goals are that you'll be able to articulate a clear research question and use language appropriate for causal or descriptive questions. I want to start by thinking about what makes a good research question. In class, we gathered several ideas about what makes for a good question. Here I'll jump ahead to what I think might make a good question. A few keys to a good research question are that first, there is a unit of analysis. The unit of analysis is a row in your data set. This could be a person, or it could be a school or a neighborhood. Whatever it is, a good research question makes clear what the unit of analysis will be. Second, we have an outcome. An outcome is some variable that takes a particular value for each unit. If a unit is a person, maybe the outcome is their annual wage and salary income. If a unit is a college, maybe the outcome is the graduation rate at that college. Third, we need a target population. This is a set of units about whom we hope to infer. The target population could be something like all adults ages 25 to 50 residing in the United States in 2023. When we define the target population, it should be clear who is included and who is not. If you had another hypothetical person come into the data set, you might be able to be clear, does that person belong in my target population or not? Fourth, and this is maybe the most difficult part, is that a good research question has the potential for surprising results. It's not really that interesting to ask an empirical question where you already know the answer. For instance, do people who are older tend to have more health issues? That's probably true. But maybe if I was trying to quantify the degree to which health issues become more common as people get older, then that would become a question for which there might be potentially surprising results. One way to ask a question with potentially surprising results is to try to make an argument for why the result might be one way or it might be the other way. If you honestly don't know which result you might find, then write down that argument, because this might help you and your readers to be really interested in finding out what empirical result you actually produce. So as one example of a research question, we might want to describe a population. What is the proportion employed among U.S. resident women ages 21 to 35? Here I have an outcome variable, employed, a unit of analysis, a person, and a target population, U.S. resident women ages 21 to 35. We could think about this question in a table. Each row in our table is a particular woman, and there's a column for her outcome, employed, 1, or not employed, 0. We could also describe population subgroups. What is the proportion employed among U.S. resident women ages 21 to 35, comparing mothers to non-mothers? We now have two target populations, a target population of mothers and a target population of non-mothers. We'd like to know how the mean employment differs across those two sets of people. Describing population subgroups is very different from a related goal, which we have not yet touched on much in this course. That's the causal effect in a population. What is the average causal effect of motherhood on employment among U.S. resident women ages 21 to 35? Now I'm about to put some notation on the slide, which might be unfamiliar to some of you. For your projects, we don't expect you to work on causal inference questions, although we'll touch on them a little bit in the coming weeks. For now, I'm going to make some notation that makes this research question a little bit more precise. For each woman in this target population, we can imagine two potential outcomes. She has an outcome. Would she be employed if she were hypothetically a mother? We'll call this Y1, the outcome realized if motherhood took the value 1. For each woman, there is also an outcome that would be realized if she were a non-mother. This is Y0. So for woman 1, she would not be employed if she were a mother. Her outcome there is 0, but she would be employed if she were not a mother. Her outcome there is 1. The causal effect for each mother in our population, or each woman in our population, is the difference between these two potential outcomes. So woman 1 would not be employed if she were a mother, would be employed if she were not a mother. So for her, the effect is -1. Motherhood causes her to be not employed. Causal inference is challenging because for each mother, we only see one of these two potential outcomes. That's a problem we'll get to more in coming weeks. Right now, I just put this up here to clarify for you that these are two very different research goals. When we describe population subgroups, we're looking at the average employment here across two sets of people. There's the set of people who are actually mothers and the set of people who are actually non-mothers. We might say that there's a mean outcome among this group and another outcome among that group. In the causal claim, we're instead focused on one set of women, and we're imagining the difference in the outcome that those women would realize if they were potentially counter to fact, exposed to two different treatment assignments, mother versus non-mother. As a general rule, in this course, we mostly want to focus on the descriptive questions at the top, unless you feel really prepared to ask the causal questions at the bottom, perhaps from your previous coursework. So as you think about asking a research question, you can think about some keywords that help you make sure you get this right. What kind of question is being asked? If your question uses words like among, across, difference, and for those who, that might tend to be a descriptive question. What's the mean employment for those who are mothers? What's the mean employment for those who are not mothers? Another set of words can be clues that the question might really be causal. Does motherhood cause employment? Affect employment? Is motherhood one of the things that impacts employment? These are also good questions, but they are a bit harder to answer because they are inherently causal questions. Between these two extremes are the murky middle words. We're going to try to avoid words in this murky middle. Is motherhood associated with employment? Does motherhood lead to employment or predict employment? The words in the murky middle leave it a little vague whether we're asking a descriptive question or a causal question. We want to encourage you to focus on the words at the two extremes here. And particularly, we would encourage almost all of you to ask research questions that focus on these kinds of descriptive words that are explicitly non-causal questions. Causal questions are important, but perhaps for another course. You can also think about this in terms of these on the right being verbs and on the left being not verbs. So generally, if you're making a statement that says predictor verb outcome, motherhood causes employment, that's often causal, and you need assumptions like a directed acyclic graph. Statements among subpopulation, there is some mean outcome, those are often descriptive. Those are the kinds of questions you probably want to ask in this class. A good project may have a very simple question. People often jump to very complicated questions, but sometimes the simplest ones can provide the most interesting and surprising results. I'd like to illustrate this first with one of my own papers, and then with a paper we worked with a previous problem set. So in a project with Lewis Donnelly, published back in 2019, we asked a question. What proportion of children born in large US cities in 1998 to 2000 was ever evicted from their home between birth and age 15? In our question, you can see that we have a unit of analysis, a target population, and an outcome. Our unit of analysis is a child. That's going to be one row of our data set. Our target population is children born in large US cities in 1998 to 2000. You could make a list of these kids. If a kid came along and was born in 2001, you would know that kid is not part of the target population. We also will look at subgroups of this target population by race and by income. Then we have an outcome. Was this child ever evicted from their home between birth and age 15? We tackled this question using data from the Future of Families and Child Wellbeing study. In this survey, parents were asked questions like, we are also interested in some of the problems that families face making ends meet. In the past 12 months, did you do any of the following because there wasn't enough money? One of the questions was, in the past 12 months, were you evicted from your home or apartment for not paying the rent or mortgage? With the answer choices yes, coded 1, or no, coded 2. These data were the basis of our answer to our research question. We had to do a few things first. Of course, it's always messy working with data. So we used a linear regression model, actually I think it was logistic regression in this paper, to fill in some missing values. And then we did some gathering of responses across the survey years to make an estimate over the entire life course from birth to age 15. But I'd like to jump on to our result. We produced this figure. This figure shows you the percent of children ever evicted by age 15. And it shows you an estimate and a confidence interval. In this class, we haven't talked a lot about confidence interval. Here they're actually Bayesian credible intervals, but many of you have seen these in other statistics classes. Our figure shows this estimate for the percent evicted in various population subgroups. In the top, we see that kids who were raised below 50% of the poverty line, 28.9% of them were evicted by our estimates. Meanwhile, it was about 5% of those who were in high-income families, where high income is defined as higher than 300% of the poverty line. When we look by race, we find that nearly 1 in 5 black families was evicted between birth and age 15. Whereas for white children and those who otherwise did not identify as black or Hispanic, it was closer to 1 in 10. We thought this was an important result. It's surprising that eviction prevalence was so high in especially some of these population subgroups. It's also a very simple question. This is the kind of question you've worked on in problem sets, where you summarize the mean of an outcome within various subgroups of the population. And it's the kind of question you could answer in your final project. You might remember in Homework 2, you read this paper by England, Levine, and Michel, published in 2020 in PNAS. This was a paper about how progress toward gender equality has slowed or stalled in the United States. You worked on figures like this one, which looks at the percentage of women and men aged 25 to 54 employed in the last week among all the people from 1970 to 2018. So we could look at this figure and think about what's the unit of analysis, what's the outcome, and what's the target population. In this case, the outcome is employment. The unit of analysis is a person. And the target population, well, there's kind of a lot of them. There's the target population of men and of women in every year from 1970 to 2018. You'll remember this paper told an important story. The employment gap closed quite a bit in these first few decades, and then that progress stalled in the decades that followed. In another figure in the paper, the authors look at the ratio of women's to men's median hourly wage among full-time workers employed in the last week, aged 25 to 54, from 1970 to 2018. So again, you can think about what the unit of analysis, target population, and outcome are here. Here the outcome is hourly wage. The target population is women and men in each of these years who are employed. And the unit of analysis is a person. I highlight these two graphs because they're familiar to you. We worked with them on a previous problem set. I also highlight them because I think they're especially clear, including in these captions of the figures, about exactly who belongs in that target population. The figure makes it really obvious which people are part of the target population and which people are not part of the target population. That's an important goal for you as well as you work on developing your final project. Now, a few hypothetical examples of questions that might not be so great for the final project or might have ways that they could be improved. So here's an example that is maybe a good question, but not really right for our class. A researcher uses a random forest, which is a machine learning tool to predict outcomes as a function of some predictors. They model hourly wage given many inputs. Cool. Then they report a measure of variable importance. How important is each variable in predicting that hourly wage? This is an important question you might answer in a data science class. It might help you to understand that algorithm better. If this algorithm was going to be used in some consequential decision, we might want to know how much each variable contributes to that algorithm's predictions. But this is why it might not be right for our class. So first off, we really want to study the world. We want to think about the mean outcomes of different subgroups in the world. This is more a study of an algorithm. How do various variables contribute to some predicted value? It would be good in a class about algorithms, but our class is really about inequality in the world. We also want a clear target population, and there isn't really one here. I haven't told you who these people are who have hourly wages. Finally, we really want an outcome aggregated within subgroups. And this is maybe interesting, but it's definitely something else. This doesn't look like the kind of question that we've worked on the homeworks in this class, so it's probably not right for our final project here. An example that could be improved. a researcher studies the racial composition of those with college degrees and without college degrees among 25 to 50-year-old American residents in 2022. Okay, this is starting to look more like the kinds of things we worked on in the homeworks for this class. But you might think, what's your biggest concern about this study? So when I look at this study, my biggest concern is that it's usually best if we have some predictor variable x, which precedes y in time, or in some sort of like causal ordering. In this case, our predictor x is college, and our outcome y is racial identification. Now, there are valid theories where one thinks that going to college might change someone's racial identification. But in most settings, we would think that racial identification comes first and college comes second. Thus, it might be better to study how the probability of completing college differs across those identifying with different racial categories, as opposed to studying how the probability of identifying with a racial category varies across those who do and do not complete college. Generally, we'd encourage you that if there's some temporal ordering of the variables, the outcome variable should be the one that's at the end of that temporal ordering. A researcher studies whether those with higher hourly wages have higher annual earnings. What's your biggest concern about this study? So, my first concern is that it needs a clearer target population. It's not totally clear who those are here. But my biggest concern is that the result here is somewhat obvious. It seems sort of clear that those who have higher hourly wages, they're probably going to have higher annual earnings. This would be more interesting if you could somehow argue that those with higher hourly wages would have lower annual earnings. Then we'd all be really interested in what you found empirically. But if you can't make that argument, then maybe this isn't the best question to answer, because it's not likely to yield surprising results. A researcher uses a probability sample survey to estimate the share of total wealth held by the top 1% of households. So this researcher is ordering households by wealth and looking at the top 1% of them and seeing how much wealth is held by those folks compared to the total wealth in the population. This seems like a pretty good question, especially if that target population was made clearer. Now suppose 30% of sampled individuals, they refuse to answer the question. So the researcher says, well, that's a bummer. I'm going to just drop those cases. I'll say that my target population is the top 1% wealth share. I guess I should say my target population is the top 1% among all the households who are willing to answer this question in the survey. And so what's your biggest concern about this study? For me, the biggest concern here is pretty straightforward. It's that the target population may not be that interesting if it excludes those who won't respond. In particular, it might be that the wealthiest people don't want to report their wealth in a survey, so the top 1% of those willing to respond, they might not even be the top 1% in the population as a whole. Sometimes you might have an interesting research question, but you find that there's just a massive amount of missing data when you go to look at the data set, and in that case, sometimes it might be best to revise your research question. So the keys to a good research question, to reiterate from the beginning, are having a clear unit of analysis, a clear outcome, and a clear target population. Adding to this, which is somehow not on the slide, it'd be great if you ask a question that has the potential for surprising results, where you really think the empirical result could go either way. Our goals today were to articulate a clear research question and use language appropriate for causal or descriptive questions. Hopefully what we've done in the course up to this point gets you excited about asking your own question, because we're excited to see what you're going to discover working on the project.